Start madam. Good evening everyone. I am Venkatesh, our 5th semester from GMU. Today we are explaining about deep learning based emotion detection system. These are our team members Saujanya, Srujan, Tejaswini and Vinay Kumar. Next slide go. These are the contents: introduction, problem statement, motivation, absorption. Next. Introduction to emotion detection. Human, human facial expression conveys emotional states such as happiness, and sadness and surprises, recognizing automatically by their faces. Our project performed recognizing in the real time using the live webcams. ಅಂದ್ರೆ ಮ್ಯಾಮ್ ವೆಬ್ಕ್ಯಾಮ್ಸ್ ಇಂದ ನಾವು ಅವ್ರದ್ದು ರಿಯಲ್ ಎಮೋಷನಲ್ ಡಿಟೆಕ್ಷನ್ ಮಾಡಿ ಅವ್ರದ್ದು ಇನ್ನರ್ ಫೀಲಿಂಗ್ ಬಗ್ಗೆ ಏನು ಅಂತ ಡಿಟೆಕ್ಟ್ ಮಾಡ್ತೀವಿ ಮ್ಯಾಮ್. ಅವ್ರು ಯಾವ ಥರ ಫೀಲಿಂಗಲ್ಲಿದ್ದಾರೆ ಅಂತ. ನೆಕ್ಸ್ಟ್ ಸ್ಲೈಡಿಗೆ problem statement. These are the problem statement. In digital and AI driven environment, emotional understanding is often missing. Machines cannot naturally understand how person feels. Therefore there is a need of such system that can automatically interpret emotion to support better interaction. ನಮಗೆ ಬೆಟರ್ ಇಂಟರಾಕ್ಷನ್ ಯೂಸ್ ಆಗೋಕ್ಕೋಸ್ಕರ ನಾವು ಏನು ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಈಗ ಈ ಡಿಟೆಕ್ಷನ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಮ್ಯಾಮ್. ಅಂದರೆ ಅವ್ರದ್ದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಕರೆಕ್ಟ್, ಅಂದರೆ ಅವ್ರದ್ದು ಫೀಲಿಂಗ್ಸ್ ಕರೆಕ್ಟಾಗಿ ಅರ್ಥ ಆಗಲ್ಲ ಅಂತ ಅದಕ್ಕೋಸ್ಕರ ಒಂದು ಮಾಡಲಿ ಯೂಸ್ ಮಾಡ್ತಿದ್ದೀವಿ. ನೆಕ್ಸ್ಟ್ ಸ್ಲೈಡ್ ವಿಲ್ ಬಿ ಕಂಟಿನ್ಯೂಡ್ ಬೈ ವಿನಯ್.
Good evening, ma'am. I'm Vinay Kumar Biyam, and I am explaining motivation and real-world impact. It will explain you how emotion detection matter, why it is matters, and here mental health. It is a long-term mood tracking support, and it is assist the doctors and the therapists to diagnosing the mental health issues and monitoring the therapy progress. And human computer interaction HCI or systems can respond differently depending on the user emotions. And educational analysis like used to measure the student engagement, and teachers can know when student are bored or confused. And well-being support technical innovations that support real human needs. And here our project overview is about face detection. It is detect the face webcam. First it will detect by the face cam, and next in emotion recognition. Once the face detected, classify the emotions, which is happy, sad or angry, using the CNN. And the user interface here display detect the emotion confidence, how much ratio it is confidence. uh, and in the performance ensure the confidence real-time processing. And evolution of the emotion detection system. Here the rule-based system. Earlier system we used manual rulers for detecting the emotions based on the facial muscle movement patterns. And future extractions like methods HOG and SVM. HOG means histogram of oriented gradients. SVM means support vector machines. And in CNN deep learning, we use model systems like convolutional neural network CNN, and more accurate and robust, faster response. And here approaches are role-based facial movement tracking. For advantages, simple interruption and low accuracy dependence on predefined rules. And HOG SVM, which is faster than manual detection, and limitations are struggle in real life and low robust. In CNN deep learning model learns expensive feature automatically, and its limitations are require computation power but more accurate. And next will be continued by Sujan.
Good evening, ma'am. I'm Sujan. The architecture consists of convolutional layers for extracting important spatial patterns for the face. The ReLU activation functions to introduce non-linearity, max pooling layer for downsampling the images and reducing computations, dense layer for feature representation, and finally a softmax layer to output the most probable emotion among all the possible classes. Coming to the next slide, here is the proposed system workflow. The overall workflow of our system can be explained in simple steps. First is the webcam captures live video, and next face detection and pre-processing are done to isolate the region of interest. The processed frame is the passed to the CNN model, which predict the user emotion and corresponding confidence score. Finally, the both emotion and confidence are displayed instantly in the user interface. So coming to the system architecture, the system is divided into two main components, the backend and the frontend. Backend is built using Flask, OpenCV, and the FER library. This handles live video processing and emotion predictions. Frontend developed using React and Tailwind CSS. This displays real-time results in smooth, user-friendly interface. Together, these components ensure fast communication and responsive emotion detection. Next slide. Technologies and stack and tools that we have used are Python and Flask for backend development, the FER emotion model for emotion recognition, OpenCV for real-time frame capture and processing, React and Tailwind CSS for creating a modern and responsive UI, and GitHub for version control and collaborative development. This combination of technologies ensured both efficiency and simplicity of implementation. This was my part. Further will be continued by Saujanya.
Hello everyone, I'm Saujanya. Now I'll be explaining about the FER 2000 dataset overview that we have used in this model. The FER 2000 dataset provides comprehensive training data for emotion recognition. This dataset has over 35,000 labeled facial images which were used to train our model. This dataset has over 35,000 images with different facial expressions, and each image is of 48 into 48 pixel resolution across 7 distinct emotions like angry, disgust, fear, happy, sad, surprise, and neutral. Angry images are about 5,000, disgust images are about 500, fear images are about 5,000, happy images are about nearly 9,000, sad images are about 6,000, surprise images are about 3,000, neutral images are about 6,000. From this we will know that more number of happy images are being trained to the model, so happy emotions are quickly recognized by the model. Next slide please. Implementation workflow. The implementation goes like this. The frame will capture, the backend continuously captures the frame from the web backend in the optimal interviews. For in every 1.5 second the emotion is detected. Image processing takes place through the OpenCV model, processes images for detecting and pre-processing. Model prediction. The CNN architecture predicts the model and recognizes the facial expression and tells the confidence. Real-time updates are also given. Immediately when we change our expression, real-time updates are predicted by the model. Next slide. Backend API response structure. JSON response format. When we run the backend, the output is in JSON format, which is very simple. Like the front end, this is the front end. This is the real time front end user interface of our model. We can see that the happy emotion is detected and the confidence is 95%. As I told you earlier, in the data sets we have fed about 9,000 happy faces to the model, so it recognizes happy very accurately. happy emotion very accurately. And on the front end, we built the user interface using the React and the Tailwind CSS. The UI requests the updated emotion data from the backend every second and the confidence automatically. Along with that, we show the live webcam feed. With that, we show live webcam feed. While the system is detecting emotions, the focus here was to make the interface simple, modern, and comfortable for the user. The next slide will be continued by Tejaswini.
Good afternoon, ma'am. This is Tejaswini. I'll be explaining about the system performance results. So, as you can see, we have mentioned the percentage of accuracy here. Around 85% accuracy for happy detection and 78% accuracy for neutral expressions. These two emotions were recognized most consistently during testing. Under good lighting conditions, the overall performance reached totally 92%, which shows that lighting plays a major role in improving detection accuracy. However, emotions like fear were comparatively harder to detect, with fear detection accuracy around only 65%, mainly due to subtle facial changes and limited dataset samples. So talking about strength, our system works well in good lighting conditions, processes frames in real time, and has user-friendly interface. The next slide. So here the challenges. During the development phase, we faced a few challenges. The first one was webcam initialization conflict, which sometimes caused delays in starting the live video feed. The second major issue was variation in lighting conditions. Emotions were harder to detect in dim or uneven lighting. And finally, syncing the Flask backend with the React frontend took some effort, especially to maintain smooth and continuous data transfer in the real time. The next slide. Yeah, for future improvements, we plan to extend the system with multi-phase emotion detection, so it can recognize emotion for multiple people at once. We also aim to train a custom deep learning model using a larger and more diverse dataset for improving further accuracy. Additionally, we plan to deploy this project as a mobile or cloud-based application, making it more accessible to the real-world use. The next slide, we have conclusion. Next slide. So to conclude, we have successfully developed a real-time facial emotion detection system using deep learning and computer vision techniques. Our system accurately identifies emotion from live video streams, demonstrate how AI can make machine more emotion aware. So it has strong potential for use in areas like education, healthcare, or customer interaction. This is all about conclusion, and thank you.
Ma'am, now I will be showing the live demo of our working project, ma'am.
Yes, please.
I will share the screen, ma'am. Ma'am, we have used two terminals for running backend and frontend separately, ma'am.
Okay.
Let me run the backend first.
Yes.
The python.server py in the VS code in our project holds all the server backend.
I am seeing here thank you slide. Who is presenting it? I think Vinay is presenting, right?
Yes, ma'am, he was presenting.
Okay. Tell him to stop presenting and start yours.
Vinay, please stop.
You will be
Yes,
running
ma'am,
the
I'll
code,
be running
right?
the code.
Yeah, tell him to stop the presentation and you can start. Yes, so
Yes,
Chana, you
ma'am,
can
I'll
start
share my
presenting.
screen. Ma'am, is my screen visible?
Yes, it is visible
Okay,
now.
ma'am, thank you. Ma'am, we have used two terminals for running front end and back end separately. I'll run back end first. The Python server.py file holds all the server backend working. I have run it first. We need backend first to operate our front end. It's running. Meanwhile, I'll run front end also. Ma'am, here we have got our HTTP link. I'll open it. Here it is, ma'am. Ma'am,
I can understand the problem. You are using Gmate, right?
yes, ma'am.
So there your camera is detecting, and here your camera is not detecting, right?
Yes, ma'am.
Yeah, you guys can come to class tomorrow, or else you guys can off there once you off in your video in your Gmate, and
Okay, I'll try, ma'am. I'll try.
yeah, try once that.
Yes, ma'am.
If it is not working, and come tomorrow to
Okay.
the college and give live demo.
Okay, ma'am. I'm trying.
Yeah.
No, ma'am. It is not able to recognize.
Yeah, because you are using your camera in the Gmeet. How
Yes,
can it
ma'am.
is come here, right?
Yes, ma'am.
Yeah. Okay. It's okay. Stop here, and you guys can come tomorrow. Tomorrow is Monday, right?
Yes, ma'am.
Come at 11:30.
Okay,
Yeah.
ma'am.
I will be free on 11th. 11:30. Come at 11:30, and give me this
Okay, ma'am.
demo.
Okay, ma'am.
Okay.
Ma'am,
Thank
any
you.
corrections, ma'am?
Yeah. Good representation. Good presentation. So I need improvements in Venkatesh and Sujan. Vinay, which part you have done? You are not audible. Yeah.
Ma'am,
Yeah. Which part you have done?
I have done methodology and objectives.
Okay.
Methodology means I am explaining motives of real world and objectives and evolution.
Okay, fine. So I need an improvements in Venkatesh and Vinay. Okay. So you guys can correct. Yes. You guys can correct in the third review. Yeah, come and give the demo of your second review. Okay. I'm audible, right?
Yes, ma'am.
Yes, ma'am.
Yeah.
We'll come to you, ma'am.
Yeah. You guys are free at what time tomorrow?
Ma'am?
At what time you will be free tomorrow?
We are not able to hear your voice properly, ma'am.
At what time you guys are free tomorrow?
Ma'am, 12:30 classes will be over, ma'am.
Okay. In the break period, you guys can come.
Okay, ma'am. 10
Uh,
o'clock.
yeah. Yeah. Thank
We'll
you.
come, ma'am.